Dubai, New York, Shanghai. These cities go down in history, standing out not only for their economic development, but also for technological advances that made it possible to create things that can be seen from far away. From very, very far away, the skyscrapers. Building upward isn't just stacking more floors on old designs, it needs a new project, design, and advanced technology. And, in fact, the challenges of building such tall buildings often mean that designers have to rewrite the engineering books. The Burj Khalifa in Dubai, the Taipei 101 in China, and the Shanghai Tower, also in China, would all be doomed to collapse if their designers hadn't found an effective solution to the problems that winds, especially strong winds, can cause in such tall buildings. The solution found by the designers of these buildings: a large and heavy ball. Taipei 101 is a beautiful building in Taiwan and an icon, costing $1.758 billion to build, with 412,500 square meters of space, 508 meters in height, and 100 floors. Taipei 101 is a true engineering marvel. Taipei 101 is iconic not for its numbers, but because it was built to withstand magnitude 7 earthquakes and winds over 450 kilometers per hour. But to achieve this milestone, the designers of Taipei 101 had to design a large and heavy golden ball with a diameter of 5.5 meters and a weight of 660 tons. That is, the same weight as 2.5 A380 airplanes, the largest passenger plane in the world. This ball, which was made by welding 41 layers of steel plates, each 12.5 centimeters thick, was installed between the 87th and 92nd floors. It spans 5 floors and hangs from 16 massive steel cables. This ball, called a tuned mass damper, has a single purpose: to counteract the dynamic effects caused by wind or seismic activity and to prevent excessive movement of the building that could compromise its structural integrity. And it makes use of a property that all objects have: inertia. If something is at rest, it wants to stay at rest. If something is in motion, it wants to stay in motion. The tendency of an object to remain in its current state is called inertia. It works like this. In skyscrapers, which are very tall buildings, the top of the building tends to be more susceptible to swaying caused by the action of the wind compared to its base, which is fixed. This imperceptible movement is completely normal and is already taken into account during the building's design process. What ensures the physical integrity of the building and prevents the risk of cracks appearing is that it yields to these oscillations. These oscillations can reach up to 1 meter of horizontal displacement without posing any risk to the building. But things change when storms and strong winds hit the skyscraper. That's because strong winds dangerously increase the oscillations, especially at the top of the building, where the oscillations can cause a horizontal displacement of more than 3 meters. And the stronger the wind, the greater the amplitude and frequency of the oscillations, which could compromise the building's structure, leading to potential collapses. And that's where mass dampers come into play. When the building starts to move and sway under the action of strong winds, the huge and heavy ball counteracts this movement. In other words, the ball moves in the opposite direction of the building's movement, providing strong resistance to the swaying caused by strong winds, which ends up significantly reducing the violence of the movement. To prevent the ball from swaying too much and especially to keep it from hitting the building during oscillations, a series of oil-filled dampers are responsible for absorbing the ball's movements and carry the energy absorbed during the deceleration of the building's oscillatory movements caused by the wind. It's incredibly simple but very ingenious. It wasn't long before a series of earthquake storms tested the gigantic ball. At the beginning of August 2015, Tropical Storm Sodelure, which passed through Taiwan with winds of over 210 km per hour, hit Taipei 101. However, the gigantic tuned mass damper efficiently cancelled out the destructive effects of the storm on the building, which caused the ball to move about 1 meter. The massive $4 million ball, one of the few seen by the public, kept the building stable. The Taipei 101 tuned mass damper is composed of 3 main parts: an isolating mass, in this case the ball, a set of dampers to absorb and cushion the force of the ball's oscillations, and a viscous damper, which is a fluid, usually oil, that goes inside the dampers and helps in the process of dissipating the forces. Taipei 101 isn't the only place using this massive ball. the Shanghai World Financial Center in China, the Princess Tower in Dubai, the Trump Tower in the United States, the Shanghai Tower in Shanghai, the Almas Towers in Dubai, and many other skyscrapers around the world also make use of this ball. You probably know that the Burj Khalifa in Dubai, the world's tallest building at 828 meters, has its own ball to dampen strong wind-induced oscillations, right? But actually it doesn't. The engineers were smarter and took it a step further by choosing a design for the building that works on its own as a damping system. This confuses the wind and drastically reduces the building's swaying, keeping the structure stable. Multiple wind tunnel tests were done to demonstrate the design's efficiency and to ensure that the wind phenomenon known as vortex shedding would not occur with the building structure. Thus, the Burj Khalifa is wide at the base but very narrow at the top, which would not allow for the installation of a huge tuned mass damper. The luxurious Burj Al Arab Hotel in Dubai also has an ingenious mass damper system. But instead of a ball, about 4 huge weights are used, suspended at specific points of the massive structures called the exoskeleton. When the wind hits the structure and the vortex shedding phenomenon starts to happen, instead of the structure vibrating, the 5-ton suspended weights begin to move, cancelling out the vibrations and keeping the structure stable. Another common way to prevent oscillations is by designing large open spaces in parts of the building, letting wind pass through and reducing pressure on the structure. And this solution was implemented in several buildings, including the World Financial Center and also in the iconic 432 Park Avenue in New York, which also makes use of mass dampers. And some buildings even use water in large pools at the top of the building to counteract the oscillations. And these were some of the solutions found by skyscraper designers to keep them stable, comfortable, and most importantly, safe while facing the great storms brought by Mother Nature. A simple principle, but very ingenious and efficient.